Welcome to this module. Thus far, we had a closer look at Angular and at Node, and we have a first basic connection between these two ends. But of course, one important thing is missing. We're not storing any data on our server. We're handling data in our Angular application, but that of course does only get us that far because it's gone whenever we reload our app. And that's not that helpful. We need to persist data on the server instead, so that our users can load that data whenever they come back to our web page, even if they come back to it from different machines. It's a website in the end, right? So on our big picture here, we're now working on that MongoDB part on the right here and on that persistent data storage thing. This is what we'll dive in this module. You will learn what MongoDB is and how you can conveniently use it from within a node.js backend. Let's connect our Node Express app to our MongoDB database. And for that, let's go back to our MongoDB cluster here and click Connect. And once you click Connect here, this window should open. And there you can choose how you want to connect. Now we will connect our application, so connect your application. We're using the latest driver. And then in the end, you can copy that address. By the way, you can also manually write down that address if you're using a local server. That should do the trick, though check out the quick start guide and the official docs if you're using your local MongoDB server. So I will copy this address here, and we connect our app to MongoDB in the app.js file on the backend. Somewhere here at the top, let's import Mongoose, because Mongoose is our package we use for working with the database, so we also use it for connecting to it. So let's import Mongoose here. And then, very early, maybe here after we created the app, we can run mongoose connect. Now, connect takes a string as an argument, and that string is just what you just copied. So MongoDB plus server. Then this entire thing, so this should work. And now password, of course, needs to be replaced with your password you generated. So that password, which I stored in that same file, this one. Let me grab it and add it here. Let's replace that entire password thing, including the lower and greater than signs, with our password. Now here it's saying max user because I named my user Max. So this part here will be different for you URL if your user is not named Max, which it probably isn't. But with that, we've got all the logic in place to connect to MongoDB whenever your Node server starts. And Mongoose will manage that connection for you, so you don't have to worry about that here. Now with that, we can close that. We are now ready to use that connection. Now one important thing, that connect method here will actually return a promise where you can, for one, output something if everything is working. So we can console log connected to database here, but we can also catch any potential errors. And whilst I won't really handle them here, you should of course be aware that things can go wrong. So here I will console log connection failed. And that could occur because maybe your MongoDB server is down, your firewall is blocking access, anything like that. So now you see I restarted this and it's saying connected to database. So this seems to work. Now we can use that connection to finally use our post model, which we created with the help of Mongoose, to save data to the database. So with our app connected to MongoDB, let's now use that post model to not just log it, but to actually save that data to the database. And for that, we can do one cool thing. We can just say post save. The save method is provided by the Mongoose package for every model created with it. And that's the advantage of this model and why we create our object with that model and not just a normal JavaScript object. So now we can save that. And what Mongoose will do behind the scenes is that it automatically creates the right query for our database to insert a new entry with that data and that automatically generated ID into the database. So that is what save will do. Now, one thing, which database is the question? We got our database connection here, but actually, this will write to a so-called test database. Because what we have here is a connection to our cluster. Test is the name of the database we're then storing the data in. So you can overwrite this and name it Node Angular, for example. So now it will automatically on the fly create that Node Angular database the first time you try to write to it, and it will create a new post entry or document as it's called. Now, if you remember, I said that documents are stored in collections though, so what will be the name of the collection? That will always be the plural form of your model name. So if your name is post, then your collection name will be all lowercase posts. So that's a collection which will be created automatically for you in the automatically created database, and there Mongoose will automatically save your post as a new document. Awesome, so much automation. So with that added here, let's see if that works. Let's save that, and let's now go back to our application, and let's try adding another post with a little bit of rolling over the keyboard content. And yeah, how can we tell if it worked? We don't get a message here, right? Now, unfortunately, in the free tier, we also can't look into our database here, so we can't really see this. Now, regarding the operations, that always has a little lag, so we can't see it here either. We don't see live updating here. So in order to look into our database, we can connect from another source. Let's click on Connect again on the cluster and connect with the Mongo shell. Now here, choose your operating system, and then you'll get instructions on how to install that Mongo shell. And you can either use the download link or, well, that link to, well, fetch it from there. And once you got it downloaded, you can use instructions. You're probably using the latest version of the shell if you use that link. So you can click on the instructions here to find out how to connect. Now let me show you how it works for Mac. It pretty much works the same for Windows. So I'll first of all download that shell. And once the download finished, I'll execute it. Now on Windows, this should give you a little installer. On Mac, it will simply unzip this into a file which looks like this. And you can then just drag and drop that into a folder anywhere on your machine, so a folder of your choice. I'll actually delete the old content and replace it with the newly downloaded one. Just drag and drop it over there. And then you open your normal operating system terminal or command prompt, where you then navigate into your folder, into that bin folder, and then you can simply run a certain command there, which again you see here on the instructions, but it's essentially the same command. So you can run this command, which you see here, copy it and hit execute. And on Mac and Linux, you will probably add a dot in front of that, /, excuse me. And now this will run that shell. And now you're connected to your database. And what you can do now is you can run certain commands. First of all, you need to add your password though. And that's the same password as you have here. So just copy that password, paste it in. And now once you're connected, you can interact with your database from that, interface here through the terminal. Now, which commands can you run? First of all, we're on the cluster. Let's switch to our database. So to the database which is created on the fly here, Node Angular in my case. We do this by running use Node Angular. And you should see that it switched to the DB Node Angular. Now here, you can run help to see an overview over the commands you can execute. And for example, what we can do is we can run show collections to see all collections that were created in that database. And you should see a posts collection there. And then you can also have a look into that collection by running db.posts.find. And this will list all the entries in this collection. And you should see one document here, which has this automatically generated ID, which has this object ID type, and then your title and your content. And if you're seeing this, then it worked, and this really is in your database. Now with that, let's go back to our app, We can see that the data was stored there. How can we now fetch it? With the data being stored, it's of course interesting to see how we can fetch it. And for that, let's go to our GET request where we are fetching posts. And thus far, we always return that dummy data back to our client. Now, that's not really the data I want to return. From now on, we can, of course, return real data. So what we want to do here is we want to fetch data from the posts collection. Now, creating a post could be done with the help of our post model, which we simply instantiated here with the new keyword. Now, for fetching data, we can use the post model again, but this time without the keyword. We use a static method on it instead, which is also provided by Mongoose. So here, that model method returns us a constructor function, which also has some static methods. And here, the method I want to use is find. Now, find, just as in the shell, will simply return all entries. Now, to be very precise, find also can be configured to narrow down the results you get. But for now, let's use that approach where we get all results. As a side note, if you want to dive much deeper, definitely check out the official docs. And here under queries, you find all the information on how to find just one element, for example, narrowed down like this, or as we are doing it for finding a lot of things, multiple entries, but then also possibly narrowed down by passing a JavaScript object where you pass field values and then the value they should hold, or more complex queries. That, however, is a topic for a course dedicated on MongoDB or Node and MongoDB. So we'll just use a very basic find operation here there, which returns all results. And the thing just is, how do we now get that result or these results and use them? Find like this can be used in two ways. We can pass a function to find, and that will be executed once it's done. And this callback will actually get two arguments, either an error or the result, so the documents it fetched. Now we can use that callback, but I don't want to use a callback. We can quickly end up in callback hell. So instead, we can also chain a then block, which is, well, working like it is on a promise. Find doesn't really return a promise, just something, an object which has a then block that behaves similarly. So we can basically use it in the same way. And this then block will then, hold our results. So here we will get back all the documents and we can use them in here. And for now, let's simply console log these documents to see what we got. Of course, we can also add a catch block to handle the case that something went wrong, but that's something I'll come back to later in the course, error handling. So for now, let's save that, and let's go back to the app and reload our Angular Frontend. This will send a new GET request, and we get an error here. We get an error because on the backend, of course, we now no longer have posts which we sent back because we deleted that posts array. Doesn't matter though, the interesting thing is that we have an output here on the backend, which looks exactly what we're looking for. An array of posts, which clearly is coming from our database. And we can work with that. So now we have this then block, and in there we get these documents, which clearly is our database data. And we see the title and content here. Now we can return that. So we put our response code into that then block now. And that's important. We must execute it inside this then block because fetching that data is an asynchronous task. So we need to wait for these documents to have arrived. If we execute our response code here, then Node and JavaScript will simply execute this line, but not wait for it to finish and immediately jump to this line, where we would then try to access something we haven't received yet. If we put our response into that callback here in the then block, however, then we're safe, and now we can rely on the documents being there. So posts now can really just be our documents, because these documents will be JavaScript objects which have a title and content field, exactly what we're using on the front end, right? Well, almost. On the front end, we expect to get an ID field, but on the back end, it's named _ID. Now, we can fix this. We can fix this by renaming it on the server. So when we get our data. We could not directly assign documents here, but call documents map, a default JavaScript function, and convert every document to have a structure where we have ID without an underscore. But I don't want to do that here. I want to send that raw data back. So I'll take care about this in a second. For now, let's save that. And let's see what happens if we reload our Angular app. And hey, this doesn't look too bad. The ID doesn't matter yet because we're not using it on the front end. And this certainly looks great. We loaded our post here, and that's the data coming from our database. So let's next worry about converting that ID thing. So fetching the data from the database is working, and that's great. But even though we're not using the ID on the front end yet, we'll eventually have a problem because on the front end we expect to have an ID with an underscore, but what we actually store, and what TypeScript doesn't know when the code gets compiled, hence we don't get an error, is that our backend data actually does have an underscore, right? You can see it here. It's underscore ID what we're getting from the database. So this is, of course, not ideal. We want to have a setup where we, well, have the right data stored on the front end. Now, we could, of course, simply rename that to underscore ID on the front end and be fine, but I want to stick to ID. And therefore, in get posts, we can simply convert the data we get back from the server before we use it in subscribe. Since the HTTP client of Angular uses observables, we also got access to the many great operators observables offer. Operators are basically functions, actions we can apply to the observable streams, or to be precise, to the data we get through these streams, before the data is ultimately handled in the subscription. So we place something before subscribe, but still chained to that observable chain, and that something is the pipe method. Now, pipe simply allows us to add in such an operator, and we can actually pipe multiple operators. So pipe is a method that accepts multiple operators we can add. Now, to use an operator, we need to import it. So we import an operator from rxjs/operators. And the operator I want to use here is called the map operator. Now, if you worked with JavaScript a bit, you probably know the map method you can use on arrays. This method allows you to transform every element of an array into a new element and store them all back into a new array. And it's essentially the same what map does here. We use it like this, and it will get executed on our observable stream. The map function here expects an argument. It expects an argument, a function which it should execute on every data that makes it through that observable stream. So in the case of an HTTP request, our response. Or since we use the HTTP client, the already extracted response body here. So what we get here is our post data, and then we can do something with it here in the body of that function we passed to map. Now that post data will actually not be this data object here anymore. It will not hold a valid post because the ID is wrong. So instead, posts is of type any. Now we know the exact type and we could define it as such, but let's say, want to save time, it's type any. You could of course be more clear about the type. So here we want to return the array of posts, and we do that by accessing post data posts, let's say. And this will automatically be wrapped into an observable by rxjs, so that subscribe still subscribes to an observable. And this now would give us the posts, so we already stripped out the message. But of course, we want to convert every post, and we'll do this with the normal JavaScript map method, which we can add to any array, and this is just an array. And in that array, we want to replace every post with a new JavaScript object. So here we return a new JavaScript object for every post, which has a title, which is post title, which has a content that is post content, but which also has an ID, which is post underscore ID, because that is what we're getting back from the backend. So now every element in the array will be converted to such an object and will be put back into a new array, which we then return here. And then this will be wrapped by an observable and be passed on to the subscription. Now with that, we also have to update our code down there where we subscribe. This should now simply just posts. We just get back the posts here, or since I have that name here already, let's name this transformed posts, any name you like, because this is now the result of our map operation. Now if we save that and Angular reloads, well, we fetch data again, but this time we will have the correct ID. And I can prove that to you in the next lectures when we'll also add a functionality to delete a post to make that delete button work. We can save data to MongoDB and we can fetch data from it. Now it's time for a new route, and that should be a delete route. So in the Node.js code in the app.js file, I'll add a new route for the delete HTTP verb with app delete, for a request that reaches API posts, and now here we actually need to encode a new piece of information into the URL. Because for delete requests, you send the ID or some identifier of the thing you want to delete as part of the URL. You don't send a request body here. So that part is encoded as a dynamic segment, because of course I can't say delete requests to API posts and this will delete a resource with that ID, because I can't define routes for all possible IDs we might have. Instead, we'll add a dynamic path segment by adding a colon and then any name of your choice, like ID. And this will be extracted by Express. You will be able to access an ID property then. And this will be the dynamically passed ID. So we send a request to API, posts, and then some ID. And here on the back end, we will be able to get that some ID value from that ID property. Now, how does that work? Let's pass that second function here, which is triggered for every incoming request. And let me there simply console log request params. That is a property managed by Node.js, or by Express to be precise, which gives you access to all encoded parameters. And we only have one, ID, so here we can access params ID. And for now, let's simply send back the status code 200 JSON response, where we send back a message, post, deleted, something like that. With that added, we got our delete route. Now let's connect Angular to that. On the Angular app, we already have our delete button here. Now it's not doing anything yet. Time to change that. Time to add a click listener to that delete button and delete a post. Now for that, I'll call onDelete, a method I have yet to add. And we want to pass information to that method. The information should be which post to delete. Now, since we're looping through all the posts here, we got post information, and that post actually is based on our post model, and therefore we have access to the ID, which is the ID coming from the database, right? That is that transformation we added here. So we got the ID from our database, therefore we can delete the post. So we can simply pass post ID to our onDelete method. Now, of course, the onDelete method is missing, so time to add that, onDelete. Here I know I'll get a post ID, which is of type string, because we actually get back that ID in string form. And now we just have to call something in our service, which sends that delete request. Now for that, I'll add a new method here, delete post. I expect to get my post ID string here too. And now in there, we can again use the Angular HTTP client to send a delete request to, well, basically the same URL as before. So let's grab that URL here, API posts. But now we add one extra segment here, and that extra segment will be our post ID. And that's that dynamic parameter. It will be part of the URL, and we can pull it out of there or from there with that dynamic segment parameter on the backend. So now we sent that request. Now again, we need to subscribe for this request to actually be sent. And there I will simply console log delete it. Now let's save all that and let's see if it works. Let's go back to the front end and hit delete here. Now I don't see deleted here. And on the back end, I also don't see anything. Yeah, because I probably also should use that delete post method I added in the service in our component here to reach out to this post's service and call delete post here and pass on the post ID. Now, side note, we will not update the array on the front end yet, so we will actually delete it and still see the post on the front end, but now it should at least send that request. So let's give that another try, delete, and we see deleted. Now if we go back, we see that output, and this is actually the parameter we fetched from our backend here, so from our URL. Now I said we won't update the array on the front end, that's true, but we also of course don't delete anything on the backend yet, so that's missing. So what we can do now is we saw that we can get access to that ID we pass as an argument. We can now use that to delete an entry in the database. And we can again do that through that post model which we created with Mongoose. Now if we check the official Mongoose documentation for deleting items, we can go to queries, because deleting something also is a query, but we actually should go to the query API documentation to get a full overview of all the methods we can call. And there, if we go up, we actually see delete one. And here we can specify which entry should be deleted. So we can call post delete one, pass a JavaScript object to narrow down what should be deleted. And the thing we're looking for is an entry which has an underscore ID, because remember, the ID is saved with an underscore in front of its name. So, or that ID field name has an underscore at the beginning in MongoDB. So underscore ID should be request params ID. Let's then add a then block to see if that succeeded. And here we will get the result of that operation. And for now, I will simply console log that result here and then also send my response. Now, if we save that, let's go back to the Angular app and click that delete button again. Now we see on the back end something happened. We got a result here. And now if we try reloading the app on Angular side, no posts added yet. Because now we can't fetch that post anymore because it was indeed deleted from our backend database. So deleting now also works, as you can see, through the delete one operation where we specify which entry with which ID should be deleted. And the ID is received as part of the URL. Now we're able to delete elements from our MongoDB. One thing you probably noted is that our frontend UI is not live updating. So if I again add a new post with some content, it's added immediately. But if I would click delete now, we would have to wait for the next reload to see that. Well, the reason for this is because we got no code in our Angular part to actually update our posts whenever we delete something. In the post service in delete post, we simply output deleted once we got the response from our delete request. Now, what we probably want to do here is we want to remove that post from our posts here and then send a new posts updated notice to the rest of our app. We can, of course, easily do that. What we can do here instead of just logging this is we, of course, want to remove our post. So we can reach out to our posts and store that in a new constant, updated posts. And there, call the filter method. Filter allows us to only return a subset of that posts array. And we pass an argument, a function, to the filter method. This function will be executed for every post in the array. And if it returns true, then this element will be kept. If it returns false, then this element will not be part of the new filtered posts array, which we store in updated posts. So my condition here is that post ID is not equal to post ID, because I want to keep all entries where this is not equal. I want to delete the one where it is equal. So with that, we got updated posts, which should be all posts except for this one. And now we can simply set this posts equal to updated posts. Of course, we could also skip this step. I'm just a fan of writing this in very clearly understandable steps. And then I will run this posts updated next and send a copy of this post. So now the whole app knows about it. If we now save this, our Angular app reloads. Let's add another post here with even more content. And let's add yet another post with dummy content. And if I reload, they all should be there. They all should be stored in a database. And now if I want to delete another post, I click delete here, and you see it's gone. And it stays gone if I reload, because it really was deleted from the database. And if we delete them all like that, they should also stay away. And indeed, they do. So now we also got that updating on the front end when we delete something on the back end. Now, we achieved a lot throughout this module, but before we leave yet to the next module, there's one thing I want to add here real quick. In our project here, if I add a new post like this with some content, and I save that post, it's added. And if I now delete that post, it stays there, right? And if we have a look at our server-side log, we actually get an error there. We see that, well, some complex error is thrown here. Something went wrong. And we can actually see that a cast to object ID failed for value null. So essentially what failed is we passed null as an ID for the post which we want to delete. And we can see that if we go to the network tab of our developer tools, there we got 2 requests at the bottom. Let me close this. And we see we got 1 pending request, which seemed to have failed. We didn't even get a response here. Now, the reason for us not getting a response here is that we don't really handle an error case on our server-side application. So here when we reach out to MongoDB or to Mongoose to delete a post, then we only handle the then, so the success case, and not really the case that this could fail. And it did fail because, as I said, the ID we passed was null. You can see that here. We see that as the request we sent. And if we have a look at that, this is the URL we sent it to. API posts null. And that makes a lot of sense, because if we go to our client-side code, when we add a new post here in the posts service, we create a post with ID null. And we instantly add this post to our front-end application to the posts there. Now, we actually do that once we got a success response from the server, and that actually means that it was saved in the database. But of course, we're not using the ID, which is dynamically generated on the server. We're not updating that ID in our local post. But that is exactly what we need to do. We're storing a new post on the server in the database, and this is proven by the fact that if I reload my front-end application, the post is there. And now we can also delete it, because now we fetched that ID, which is part of the database, or which was created for the database. But we don't do this when the post is created the first time. Now, there are 2 ways of solving this. The first approach is that in add post, in the posts service, whenever we got the success response, we actually call get posts. We could do this. This would fetch the updated posts and update our posts in our front-end application. We could do this, but it's also kind of redundant. Why would we fetch and update all posts if we simply added 1 post? So a better approach might be to simply get back the ID of the created post and use that here in the add post method. And for that, we can go to app.js, to the route where we do create a new post. And here, on the save method, we can actually add a then block here too. And here in that then block, we will get a result object with information about the result of this save operation. Let's log that result for now to see what's inside of it. This restarted our server, so the old error is gone. And now let's quickly add a dummy post here, go back to the backend, and we see what we get back. That result actually simply is the post that was created. Now that's awesome because here we got that ID we're interested in. So what we can do is we can simply take our response, which we're sending, and put it into that then block so that we send it once we know that we successfully saved this. And again, we're not handling errors here yet. We will do so later. So for now, we're just doing that. And now besides our success message, we can send back some post ID field, which simply contains result ID. And we can, of course, also rename result to created post if that's clearer. So the created post ID, that is what we're returning as part of our response. And now we can use that in our posts service. There in the subscribe method, we get back the response data with that nice message. Now we don't care about the message obviously, but that ID, that is really interesting. So here we can get our ID, the post ID, can be fetched from response data. And on the response data, we now know that we also have that post ID field, which will hold a string. So in the post service, we can update our expected return value here to also reflect that post ID field, which is a string. And we want to store that post ID value in our post ID constant here, which is not related to that post ID. We could also name that just ID. And now all we have to do is update the ID of the post we created here. So we can access post ID and set it equal to the ID we fetched here. As a side note, if you're wondering how we can edit this constant, well, we don't override the value that is stored in the constant, which is this object. We still have the same object, but since objects are reference types in JavaScript, we can safely access one of the properties of that object whilst keeping the object itself. So we only overrode one value inside of the object, not the entire object. Hence, this is perfectly valid code. Now the ID was updated, and we then stored a post with that updated ID. Now if we save all, it will automatically restart the server and the Angular server. We can add another post here with more content. And now if we hit save post, it's added. And if I hit delete here, it's also deleted. And if we now reload our application, it's gone, because now we get the real ID, which we need for the database to successfully delete this. We get that ID when we create a post. And now with that, we can move on to the next module, where we will continue working on our front end, make sure that we can edit posts, and do a lot of other cool things to advance our application. So what was MongoDB again? Well, MongoDB is a NoSQL database which stores documents and collections. And if you're coming from a SQL background, as many web developers are, well, documents would be your equivalent to records, kind of, and collections would be what you know as tables in SQL. So it's a database. It runs on a server. You store application data there, like your users, your products, or in our application, the posts. It enforces no data schema or relations, so the individual records can actually be structured how we want. And whilst we can add some type of relations, relations play less of a role than they do in SQL. And it's easily connected to Node and Express. That's also great about MongoDB. We can easily add it to a Node Express backend, not directly to Angular though. And I'll come back to this in a few minutes. So overall, MongoDB is a powerful database, which we can easily integrate into our Node Express environment, which of course is great because that is exactly the environment we have in that course. Now, one thing that's really important to me though, we will use MongoDB here because that mean stack thing is really popular. But you could theoretically swap it for any other database. So for any SQL database like MySQL if you preferred this. So that of course leaves one question. Why are we using MongoDB and what's the difference between MongoDB or NoSQL databases in general and SQL solutions like MySQL? So NoSQL versus SQL. What's the difference? How do these database systems and concepts differ? And why are we using MongoDB here? So what's the difference? We got NoSQL and SQL databases. For NoSQL, examples would be MongoDB, which we will use in this course, but also CouchDB, for example. And for SQL, we would have MySQL, Microsoft SQL. These are just some examples. There are more solutions, of course. Now, NoSQL databases enforce node data schema. So in one collection, you can have records with different structures. They might have a common trunk, but then maybe one entry has an additional field which another entry does not have, for example. One advantage of that is, for example, if your application changes and now you want to store the old information, but additional fields, you can do that in the same table or collection as it's called here as before. And some older records will simply not have the new fields, whilst your new records will have it. Now, in SQL databases, you typically have a more strict data schema, and all records in a table have to have the same look and the same schema. A NoSQL database also is less focused on relations. You can still create relations by storing the ID of one document, as it's actually called, of one document in another document, but they play less of a role than they do in SQL. In SQL, it's all about having these normalized data tables where one table stores the users, the next table stores the orders. And that's not bad, and that's actually also something you can build with NoSQL, but NoSQL puts less of a focus on that. We also have independent documents, whereas in SQL, records tend to be more related. And that really is just the summary of that data schema and relations thing I already mentioned. So documents simply are more on their own. They can be related, but they don't have to. They can follow a certain schema, but they don't have to. And NoSQL is therefore great for data where the structure might vary, where you have a lot of throughput because it's very fast to query, because you have less relations where you need to do complex queries. Instead, you typically query for one collection, just a bunch of documents without creating all these queries and these joins. There are no such joins in NoSQL. So therefore, it's great for things like logs, orders, chat messages. SQL, on the other hand, tends to be great for shopping carts, contacts, and in general, complex social networks, these kinds of things. Now, one thing that's really important though, there is no hard restriction for either of that. So you can absolutely build a social network with NoSQL databases and the other way around. Additionally, in bigger apps, you often have multiple database systems getting used. So you might have a NoSQL database for one type of data your app generates and a SQL database for a different part. So you can mix and match them. In this course, I use MongoDB simply because that mean stack turns out to work together really well. It's fun to query NoSQL data with JavaScript and with Angular, therefore, because it happens to be stored in a structure that looks and feels like JSON. That's very easy to work with. Additionally, a lot of mean stack apps are apps where you might end up with a lot of read actions. So often a NoSQL database is a great solution there, but overall you could swap it. For an app of the size we built it in this course, it will not matter that much, to be honest, but since mean overall is a thing and a skill or a set of skills which is in high demand, we will use MongoDB. And the way you connect it to Node and therefore also to Angular is of course something that doesn't change that much when you use a SQL solution. Now, before we finally dive into the code, there's one thing I get asked quite a bit, and it can be an obvious thing to think about. Why don't we connect Angular to the database directly without sending a HTTP request to Node, which then does the database connection thing? We could have our Angular app and our MongoDB database on a server, and we could directly send queries to the database from our Angular app and surpass our Node Express application. Technically, that would be possible. Is that a good thing to do, though? No. The answer is no. It's highly insecure. And why is that? Because secure authentication is not really possible. We have to we have to authenticate to the database, and that is done through credentials, which we would have to store in Angular's code. Now, that code is compiled to JavaScript in the end, and it's loaded into the browser. And in the browser, everyone can view it. Every user of our webpage can access our JavaScript code. Hence, we shouldn't store important information, or especially not credentials, in there. And we would have no way of storing these securely. So that is a huge issue. We would expose credentials, which then allow way more than we wanted to allow. And therefore, our full database would be exposed. So users can probably then do more than we want them to do. And therefore, directly connecting Angular to MongoDB is not a good idea, not something you should ever do, and not something we will do in this course. We will instead send an HTTP request to Node, where users can't send a different one because Node only accepts the requests we define it to accept. And then Node has all the credentials, but the node.js code can't be read by our users because it resides on a server. So that was a lot of talking about MongoDB and so on. Time to finally set up our Mongo database and then, of course, connect it to our Angular Node Express application. How do we do that? Well, we need a Mongo database for that, and a good place to start is mongodb.com. Now, you get two options when it comes to setting up the database. You can download MongoDB onto your machine and set it up there. On MongoDB, you can click that download button, which you should find there. That should take you to the download center, and there you can choose the community server, where you can choose your operating system, the latest stable release, download that file, and then on the following page, you actually don't need to sign up. You can skip this, or the download will start automatically, to be precise. And thereafter, you can dive into the documentation, like the quick start guide, where you will be instructed on how to install this. Now, for this course, I'll use a different solution, a cloud solution. There is a free sandbox available, doesn't cost you anything, and totally is enough for the purposes of this course. For real apps, of course, you will probably need a paid solution, but that's also true if you host the server on your own. And that free sandbox will be a cloud-hosted Mongo database, which you can conveniently use and which you can then use from your Node Express app you're building on your machine and you'll be deploying on a real server later. So after you clicked on Free Sandbox, you can click on Get Started for Free to be scrolled down. Then you can create an account here where you won't need a credit card, as you can see. And once you did all that, you can sign in. A step to which I will fast forward because I already have an account. Now, once you are signed in, you should be in a new project, or at least have the option to click Build a New Cluster. If you have to create a new project first, simply give it any name of your choice. The other settings should be okay. So then you can build a new cluster and there choose AWS. So basically always where you see that free tier available thing, use North Virginia. So in this case here, go down, and then for the cluster tier, you want to go with the cheapest shared cluster where it also says free next to it. So with that, you can continue. Choose the default settings down there. Basically, you will always have the cheapest settings, obviously, since it should be for free. You can leave the cluster name as it is and then click Create Cluster. Well, check that you're not a robot. And once you're done, this will configure a so-called MongoDB cluster for you, which is a server that hosts a Mongo database, a MongoDB database. And it's a cluster because it's actually a combination of multiple servers, or it can be such a combination to be precise, so that your database is horizontally scaled if it needs to be. However, not for our cheap free tier option here. Now, as it correctly prompts us, we can already have a look at the security settings now with that cluster getting initialized. And you want to add a MongoDB user here. So under security, MongoDB users, click add a new user. And there you basically want to create an Atlas admin or anyone who has read and write access to any database. So we want to give the user relatively big access rights. You can then enter a username here, like Max, and then auto-generate a secure password, which you should copy and store safely. And I will store it in my code for now. Just copy it in here. Of course, that's not the place where we will store it in the end. Click Add User. And with that user added, that will be the user which is able to access our database. Now we also want to add an IP whitelist and add an IP address here. And there you can simply choose your current IP address. Just keep in mind, throughout this course, if you work on that project over a couple of days, your IP address might change. So you probably want to update it here in case you're suddenly seeing that you can't access your database anymore. You could, of course, also allow access from anywhere, but I want to use my local address. Now, important, once you deploy your application, this should, of course, be the IP address of the server you deployed your app to, because in the end, it will be your Node.js server, which is accessing the database. It just happens to run on our machine. So let's click Confirm here for the security whitelist. And now with that, we got that all set up. Now, this will take a while, and here our cluster will take a while. And whilst this is taking a while, we can go back to our project and already install a package that helps us connect to that backend database. Now we'll have a look at this in the next lecture. So in the last lecture, we started setting up our MongoDB on a cloud storage, or maybe you installed it locally. In both situations, or in both ways, you have a database, at least soon, and now we need a way to connect to that database from within our NodeExpress application. And for that, we'll use a third-party package. Now, actually, there are two packages we could use. We'll install it with npm, so the command will be npm install --save to also store an entry in the package.json file. And now we could use the normal MongoDB client package. You'll also find a link to that on the MongoDB page. If you scroll up there, here on Docs, you can access the official documentation. And then here you can click on Getting Started. And there you find a Node.js section where it explains to you how you can connect to it. And this code here actually uses this MongoDB Node.js driver, which you can download by following the installation instructions here. And as you can see, the package name would be MongoDB installed through Node's package manager. Now we'll not use that driver. This is a fine driver and you can access your database with it. You can also access it directly from your shell, by the way, but we'll not do this for now. But I want to use a different package for accessing MongoDB. I'll use Mongoose. Mongoose is a third-party package which builds up on the official MongoDB driver, but it makes accessing MongoDB much easier and more convenient. It does something which I told you that MongoDB does not really use. Mongoose uses schemas, so you can define how your data should look like, and that allows you to conveniently store and fetch data. Now, obviously, this might not be the solution you're looking for if you have the requirement of very unstructured data. But often that's not the case. And therefore, Mongoose is a great tool that could even work with such unstructured data, by the way, but especially if you have structured data, if you have a certain model you use. So Mongoose is the package we'll use, and we simply install it by running npm install --save mongoose, like this. in your project folder. So now this will download and add this dependency. And this tool will then allow us to connect to our MongoDB server and also to interact with it, to store data and fetch data. For now, storing and fetching means storing and fetching posts. So in the next lecture, we'll actually start creating a schema for our post data in our Node.js app before we then finally make that connection to MongoDB and, well, start storing and fetching our data to and from there. So with Mongoose installed, let's use it. On Node.js, so on our backend, we'll add the schema for that. Now, first of all, let's go to our post model on the front end in the Angular code, and this shows us how a post looks like right now. A post in our application mainly has a title and a content. It also has an ID, but this ID will be created automatically by Mongoose for us. So that's another convenience option. We get that out of the box. We don't have to create such a unique ID on our own. So we can instead focus on creating these schemas on the backend. And for that, I'll create a new folder there and I'll name it models too. Model, schema, we'll basically use it interchangeably here, though actually Mongoose will differentiate between these two terms, and you'll see how in a second. So in the models folder, in the backend folder, I'll add a new file and I'll name it post.js, because here I want to create my post model using Mongoose. For that, I'll first of all import Mongoose, const mongoose, by using that require syntax where I require the Mongoose package, of course. Now with that imported, we create a so-called schema. That is how Mongoose works. You first of all create a blueprint for how your data should look like. So I'll create a new constant and name it post schema. The name is up to you though. You could name this constant however you want. And then I'll use the imported Mongoose package, and there we actually have a schema method we can call with a capital S. That's important. So we'll call schema here, and to schema we pass a JavaScript object. This object will hold our custom configuration. Now how does such a schema configuration look like? Well, we define the fields and the types of data we want to store in these fields our posts in this case should have. So we simply add a property here, title, and that is named title because I want it to be named title, because we also named it title on the front end. You could, of course, name this however you want. Title, and then the type. In its easiest form, you can just add string as a type here. Just one important note. Here in Node.js, it's a string with a capital S. On the front end, in TypeScript, it's with a lowercase s. Now, don't confuse these two. TypeScript, lowercase s, Node.js and JavaScript in general, uppercase s. So this is the simplest form of defining the title, but Mongoose actually gives you more power than that. You can pass more details than just a type by passing a JavaScript object as a value for this title prop. And there you can now define the type, which again is string. But then you can also add some extra metadata, like for example, you could say required true. Now you can learn more about that in the Mongoose docs. If you click on read the docs, then you actually see a nice introduction to that whole schema thing and in general how Mongoose works. And you can learn more about schemas and what you can add there. Then you can click on schema type here, or on the left, schema types. And then if you scroll down a bit, you see that here one schema type is required. Another one would be default, for example. You could provide a default value here. That, of course, does not really make sense if you have required set to true, but if it's not required, then you could provide a default value like hello. Of course, this does not make sense here. Instead, I want the user to enter the title, but I do require this. And therefore, we will actually get an error if we try to create this without having a title property set. More on creating data based on that schema later. So title is one thing, the content is another field, and it's a bit boring, but it looks exactly the same. It's also required true. And of course, feel free to leave out required and instead set a default value for one of these fields. But for now, this is the schema I want to work with. We'll later revisit this and work on it a bit more. Now with that schema defined, Mongoose needs a so-called model to work with it. The schema is really just a blueprint, not the thing we work with in our code, just a blueprint. In order to actually create data or create models, objects, based on that definition here, we need to turn that definition into a model. And we do that by using the Mongoose model function. There we pass two arguments. The first one is the name of the model, and here this should be post in our case. The name is up to you, but it should start with an uppercase character, and it should of course make sense for the kind of data you're storing. So here I'll name it post. And the second argument is the schema you want to use. So in my case, the post schema. Now it's important that I of course also want to use this outside of this file. So it's this model which I'll export with the help of the module.exports syntax. Now this Mongoose model can be used outside of this model file. So with this setup, let's use it in the app.js file when we do send a post request to API posts. So with our post schema and model created, we can use that to actually create JavaScript objects based on that model, which ultimately allow us to do one magic trick. So first of all, without the magic, let's create a post object. Thus far in our app post route here, so API posts, where we handle that post request, we only extract the post data and we console log it to, well, the console. Yeah, that's nice, but not really all we want to do, right? Instead, it would be better if we could store it to the database, and we'll use our post model for that, because the post model created with Mongoose will actually be the bridge from our Node.js Express app and its code to the MongoDB database, without us writing any Mongo code or anything like that. So, first of all, what I'll do here is I'll import something. I'll import my post model, and you can name this however you want, but the convention is to always use a capital starting character here to indicate that this allows you to define a new object based on, well, some blueprint. And that blueprint is our schema combined with the model, of course. So now we can require that, and we require it from that file in the models folder. So from the post file without an extension in the models folder. So now we got that post constant here. Now we can use that constant in our post route to create a new post based on our body data. So what I'll do here is I'll actually create a new post like that. That's pretty cool. We can instantiate this because turns out what the model method gives us here is simply a constructor function, which allows us to construct a new JavaScript object. And to that post model here, we pass in a JavaScript object where we, well, pass the data we need for our schema. So we pass in a JavaScript object which has a title and a content. So let's do that. Let's pass the title here. Title will be request body title because that is what we get sent to this endpoint. And the content should be request body content. And now we have a post object that's actually managed by Mongoose and that's pretty close to being connectable to the database. So let's comment out this password, which we'll need soon. And let's save everything. And let's restart all our servers. So remember, we bring up our Node.js server by running start server. So let's copy that. npm run start server. And in a separate terminal window, we start our local Angular server with ngserve. With that up and running, let's give this a try. And let's add a new post here with some awesome content. And let's hit that save post button. And now let's go to our server-side log. And here we indeed see this object is getting logged. And you can already see one cool thing. It has that ID. Remember, I mentioned that this would be generated automatically by Mongoose. So we have that ID already, Besides that, it looks like a normal JavaScript object, but actually it isn't. We can do way more with it. We can use that object to directly save it to our Mongo database. There's just one thing missing. We need to have a Mongo database connected to our Node app. And whilst we have a Mongo database up and running, by now at least it should be running, this one, we haven't connected our app yet. So time to do that in the next lecture.